All right, let's get started. Good afternoon, everybody. Welcome to the annual technical review workshop for the SONGS Wheeler North Reef Mitigation Project. My name is Kate Huckelbridge, and I'm a Deputy Director for the California Coastal Commission. Before I turn it over to Dan Reed and Steve Schroeder, I wanted to go over a few logistical items related to the Zoom platform and describe how we will run the webinar. First of all, we are recording this webinar, and we will plan to post a link to that recording on the UC Santa Barbara SONGS Mitigation website, and we'll provide that website address at the end of the webinar. Everyone attending the webinar has been muted and will remain muted during the presentations, and video, I believe, has been disabled for all attendees. If you have a question for the team at any point during the webinar, there are several ways in which you can ask your question. First, you can type your question into the Q&A box at the bottom of your Zoom screen. And we can either, somebody from the team is going to be monitoring that during the webinar. If they can answer it quickly through the Q&A box, they'll do that. Otherwise, when we come to the question and answer portion of the webinar, we'll walk through some of those questions and as time allows, answer them verbally. Second, when we come to the question and answer portion of the webinar, you can use the raise your hand function, also located at the bottom of your Zoom screen, to indicate that you would like to ask a question. At that point, I will unmute you one at a time, and you can ask your question to the team. If we are not able to get to all of the written questions, our team will try to put together brief written responses to be sent out after the webinar. Or you can always reach out to one of the team members via phone or email with your questions, and we will respond to you directly. And there will be some more information about how to contact us again at the end of the webinar. Okay, so with that, I will turn it over to Dan Reed and Steve Schroeder to go through the first set of presentations.
Okay, start video. Hello, everybody. As Kate said, I'm Dan Reed. I just want to give a short, brief introduction to the Reef Mitigation Project and tell you a little bit about the brief overview of its history and its objectives. The project is one component of a comprehensive mitigation program that is designed to offset the damages to the marine environment caused by the operations of SONGS Units 2 and 3. The other major component of this mitigation program is a wetland restoration project that is being done at San Dieguito Lagoon in Del Mar. There'll be a similar public webinar on May 4th for that project to report on its status and findings. So the operations of SONGS Units 2 and 3 rely on a single pass seawater system to cool their nuclear reactors. And that system consists of a intake pipe, a seawater intake located about a little over a half-mile offshore and 30 feet of water. That intake is connected to a large 18-foot diameter pipe that then delivers seawater to the power plant. Now, each system has its own cooling water system, and the two systems combined when the units were operating fully amounted to 2.4 billion gallons of seawater a day, which is equivalent to an area, a square mile, 12 feet deep. Well, that water, as it circulates through the power plant to cool the reactors, is heated about 19 degrees Fahrenheit above the ambient temperature. And then it's discharged back out into the ocean through these discharge lines. Unit 2 line is 8,600 feet long, extends 8,600 feet offshore, where the Unit 3 line extends about 6,000 feet offshore. Now, both of these lines, the last 2,500 feet of these lines is equipped with 63 diffuser ports, which are designed to rapidly mix the heated effluent with the surrounding seawater to quickly dissipate the heat. Now, the reef mitigation for SONGS is linked to the adverse effects of the cooling water discharge on the Santa Onofre kelp forest, which is located just offshore the power plant. A little bit of history here. The Marine Review Committee was commissioned to do extensive studies during the mid-1970s and 80s to assess the impacts of the cooling water system on the living marine resources. And one of the results from those studies showed that the rapid mixing of the effluent with the surrounding seawater created a turbid discharge plume. You can see it kind of emanating from the discharge lines in this photograph here. And that turbid plume drifted over the San Onofre kelp forest and was implicated for causing a reduction in about 200 acres of the kelp forest. So adverse impacts such as this are required by law by the California Coastal Act to be mitigated. And the California Coastal Commission is the agency responsible for implementing the Coastal Act. So to mitigate the impacts to the San Onofre kelp forest caused by the operations of SONGS Units 2 and 3, the Coastal Commission required Edison to construct an artificial reef that was large enough to support at least 28 tons of fish and 150 acres of medium to high density adult kelp forest. And that was to compensate for the losses of just not kelp and kelp bed fish, but also the invertebrates and algae that occupy the kelp forest. And the 28 tons of fish standing stock on 150 acres of kelp, those numbers were what the Marine Review Committee studies determined to be the adverse effect size caused by the operation of the power plant. Now, another requirement that the Coastal Commission imposed upon Edison is that they provide funding for scientific oversight and monitoring of the mitigation project that is independent of Edison. And that monitoring is being done by a team of scientists at UC Santa Barbara, led by myself and doctors Steve Schroeder and Mark Page. We are assisted in our efforts by Professor Mark Steele from California State University at Northridge, and Mark is helping us with studies on fish growth, reproduction, and feeding. We also have a science advisory panel that is led by Professor Rich Ambrose from UCLA and includes Professor Pete Ramundi from UC Santa Cruz and Professor Rush Schmidt from UC Santa Barbara. So the objective of the Reef Mitigation Project then is to replace the marine resources that were damaged or lost in the San Onofre kelp forest due to the operations of SONGS Units 2 and 3. Now, as many of you know, those units are no longer producing energy, but they were operational for a period of a little over 30 years. And during that time, impacts were accruing during that operational period. So the idea of the project is to mitigate for the damages during that operational period of SONGS Units 2 and 3. And the decision by the Coastal Commission, the approach to take then was to build an artificial reef and sandy habitat that is low relief with topography and depth that's similar to the San Onofre kelp forest, but it's located in the vicinity of SONGS, but outside the influence of its discharge. And the idea here is that if we could build a reef that kind of mimicked the physical structure of the San Onofre kelp forest in an area as close to the San Onofre forest as possible without exposing it to impacts from the power plant, then we'd most likely have a chance of replacing resources in kind and in the area in which they were lost. Second component of this approach was to build that artificial reef in 2 phases. The first phase is a small experimental phase that was used to test different reef designs and materials. That experimental phase was studied over a 5-year period, and then results from that experiment were then used to inform the design of a second phase, a much larger phase that was designed to mitigate or replace the kelp forest resources that are lost at San Onofre. And so that is about at least 150 acre phase that would then be followed over the operational life of SONGS Units 2 and 3. A third component was to monitor the artificial reef to measure its success based on performance standards that were developed to ensure that the project objective is met. And then to impose corrective measures to remediate the artificial reef if it failed to meet those performance standards. And lastly, the project would end, the monitoring and oversight of the project would end after the mitigation requirement is met. And You'll hear more about the details of that mitigation requirement in the next talk by Steve Schroeder. So here's the project site then. This map shows the locations of the phase 1 and phase 2 reefs. The purple squares that you see here are the phase 1 modules. There was 56 of them that were built in the summer of 1999. They're arranged in 7 clusters of 8 different reef designs. As I mentioned, information from these different designs were used to inform the design of the phase 2 reef, which was completed in the summer of 2008. It's shown as these 18 green polygons that are distributed across about a 2.5 mile long stretch of coastline. There was 150 acres in those phase 2 polygons, and together with the phase 1, it comprised 174 acre Wheeler North Reef. Now, these are some underwater images taken on the reef to give you an idea of some of the marine life that's down there. The 2 images on the left show pictures of barred sand bass and kelp bass, which are 2 of the most abundant fish on the reef in terms of biomass. They're also very prized recreational fishes. Spiny lobster also, it's an important predator on the reef. It's actually very abundant on the artificial reef. It too is prized for both commercial and recreational purposes. And we see occasional visitors to the reef by giant sea bass, which are federally protected species. They're endangered, and the reef is providing habitat to them as well. So those are all good signs that the reef is actually quite healthy and doing quite well. The monitoring results, however, after a number of years showed that the 174 acres of the Wheeler North Reef in its present configuration was just too small to consistently meet the performance standards that required it to support 28 tons of fish standing stock and 150 acres of adult giant kelp. Consequently, in 2016, the Coastal Commission informed Edison that they were required to remediate the Wheeler North Reef by adding up to 210 new acres of low relief reef. And I'm referring to that as the phase 3 expansion of the Wheeler North Reef. And here's where that expansion was taking place. The phase 3 expansion shown in white here. It consists of 20 polygons that comprised a total area of 197.4 acres. A couple of those polygons were located at the southern end inshore of the phase 1 and phase 2 reefs, where the remainder of the phase 3 expansion was built north of the existing reef, along about another 2.5 mile stretch of coastline. Collectively, all 3 phases comprise about 373 acres of reef. I mentioned that monitoring is done, and the purpose of that monitoring is to determine whether Wheeler North Reef is meeting the required project goals as measured by these performance standards that were established. Sampling is done at fixed stations. They're 50 meter by 20 meter areas that are broadly distributed across all 3 phases of the reef. These black lines that you see in the polygons are the locations of those sampling stations. There's a total of 92 of those stations in the phase 1 and phase 2 reefs, and an additional 57 spread across the phase 3 reef. Now, each station is defined by a differential GPS coordinate and a compass heading, and they're sampled once per year in the summer to early fall. There were some impacts of COVID-19. I mean, these impacts were relatively minor relative to the grand scope of the pandemic, but one of the impacts was that the university-sponsored research was shut down from mid-March to mid-July in 2020. And so this delayed the start of our monitoring for about 2 months. And once we were allowed to resume our research, there were restrictions that were placed on the number of people that we could have on a boat, the size of our dive teams, and all this led to a reduced sampling effort for the 2020 performance standards. And this reduced sampling effort led there a reduction from the original 92 sampling stations in the phase 1 and phase 2 reef to 15, which are shown as these yellow markers here. And this reduced sampling had increased the uncertainty in assessing some of our performance standards. And And Steve Schroeder will talk about that in the next talk. So following Steve's talk, then we'll have time for questions and comments pertaining to the monitoring results. And after that, then we'll move on to talk a bit about some of the details of the expansion of the phase 3 reef. And that again will be followed by questions and comments. So with that, I'm going to turn this over to Steve Schroeder, who will discuss results on the 2020 performance monitoring.
Okay, thanks, Dan. Minimize that. Okay, so this talk is summarizes the performance monitoring of the Wheeler North Reef for 2020. And next slide. Okay, so the performance standards are used to evaluate whether the Wheeler North Reef compensates for the loss of kelp forest habitat caused by the operation of songs units 2 and 3, as Dan has pointed out. There are two kinds of performance standards. The first are relative standards that must be similar to natural reefs in the region at the Wheeler North Reef. And the second are absolute standards that are measured against fixed values at the Wheeler North Reef only. So to be successful, let me see if I can get rid of this. Okay, there we go. For the first, turning to the relative performance standards. This requires comparison to natural reference reefs in the region. And the rationale here is that to be successful, the Wheeler North Reef must sustain a kelp forest community that is similar to those of natural reefs in the region. The criteria for choosing the reference reefs is first, they have to have a history of sustaining giant kelp. They must occur at a depth similar to that of the artificial reef. They must primarily be low relief, preferably consisting of cobbles and boulders, similar to the impacted kelp forest, the Onofre kelp forest. And they must be located within the local region, and as Dan pointed out, far enough from the power plant not to be impacted when the power plant was operating. The kelp forests at San Mateo and Barn best met these criteria. So this slide you can see the Wheeler North Reef, phases 1, 2, and 3. The San Mateo kelp forest is just south of the Wheeler North Reef. And the Barn kelp, the second reference site, is about 12.5 kilometers to the south of the Wheeler North Reef. Again, the relative performance standards must be similar to natural reference reefs in the region. And the definition of similar is that the 4-year running average for a given relative performance standard at the Wheeler North Reef must not be significantly less than that at the reference reef, having the lowest value for that particular performance standard. And the rationale here is that for a given relative performance standard, the Wheeler North Reef should perform at least as well as the lowest performing natural reef used as a reference site. The biological characteristics of a reef, natural or artificial, fluctuate over time, and a 4-year running average is used to take into account this variability when evaluating the reef performance. Okay, there are a total of 11 relative performance standards. Standards 1 through 5 pertain to the benthic community of algae and invertebrates. Standards 6 through 10 pertain to the fish on the reef, resident fish density, young of year fish density, fish species richness, fish reproductive rates, and fish production. And the final standard is termed food chain support. And this is a measure of how the benthic community provides resources to the reef fish community. Okay, so I'm going to go through these different standards, and the format is going to be similar on the next several slides. So on the left hand, there will be one or two panels that show the annual time series. The Wheeler North Reef is indicated by the green up-pointing triangles. Barn kelp is indicated by the blue squares, and the San Mateo kelp bed is indicated by the red circles. And then on the right are the 4-year running averages for the particular relative standards. So first, if we look at the percent cover of algae, what you can see is initially when the reef was put in 2008. In 2009, when we started the monitoring, Wheeler North Reef was had value between the two reference reefs, but thereafter it's been consistently below the reference reefs. And this is indicated in the running average, which shows Wheeler North significantly below the two reference reefs. And therefore, this standard has not been met in 2020. The next standard for algae is the number of species, the average number of species per transect, and it shows a pattern roughly similar to that for the percent cover, starting similar to the reference reefs in 2009 and then being consistently below the values for the reference reefs thereafter. And again, the 4-year running average shows that this is the case. As a result, this standard has not been met. So the two standards for percent cover of algae and the number of species of algae were not met in 2020. The next two standards pertain to invertebrates. The percent cover of sessile invertebrates and the density of mobile invertebrates must be similar to natural reefs within the region. And what you can see with the cover of sessile invertebrates, Wheeler North Reef started below the two reference sites in 2009, but over time has been either above or sort of within the two reference reefs. This is reflected in the 4-year running average, where Wheeler North was actually, the 4-year running average was actually the highest in 2020. And so this standard was met. And the next standard has to do with the density of mobile invertebrates. Again, Wheeler North started out low in 2009, and abundance of the mobile invertebrates increase is actually from 2012 to 2015 is actually higher than two reference reefs, and thereafter sort of had intermediate values. And the 4-year running average in 2020 shows Wheeler North Reef is actually higher than the two reference reefs, and so this standard was met. So these two standards for invertebrate, the invertebrate assemblages on the Wheeler North Reef were met in 2020. Okay. This next standard has to do with the number of species of invertebrates. So this combines both sessile and mobile invertebrates. And what you can see here is that the number of species started out much lower than the two reference sites through 2011, and thereafter they've been pretty much within, or in some cases slightly above, the values for the two reference reefs. And in the 4-year running average, Wheeler North Reef was not lower than the lowest performing reference reef, the San Mateo kelp. And so this standard was met in 2020. The next few standards now have to do with fish assemblages on the reef. There are two standards here. One is for resident fish, that is to say reef fish that are over a year old on the top two graphs, and the bottom two graphs has to do with juvenile fish or young of year fish. And what you can see here for resident fish is Wheeler North Reef, with kind of the one exception of 2011, where barn kelp had very high abundances, pretty much followed the abundances of the two reference reefs, being either slightly above or with between the values. And this is also reflected in the 4-year running average. So the standard for density of resident fish was met. Looking now at the young of year fish, what one can see is that Wheeler North is pretty much follows along the same annual trajectory as the two reference reefs. And for the 4-year running average in 2020, this standard was met. So these two standards of abundance of fish were met in 2020. Right. Okay, let me go here. Okay. The next two standards have to do with the number of species of reef fish and productions of reef fish, and both must be similar to natural reefs within the region. So if we look on the upper two graphs, the number of species per transect at the Wheeler North Reef is pretty much, by and large, in between the values at the two reference reefs. This is also reflected in the 4-year running average in 2020. And so the standard for number of species of reef fish was met in 2020. The next standard has to do with production, the grams per meter squared per year. What you see is that, again, the annual time series for the Wheeler North Reef pretty much is between or slightly above that of the two reference reefs. And for the 4-year running average in 2020, it was actually higher than both reefs. And so this standard is met. So these two standards, number of species of reef fish and the production of reef fish, were met in 2020. Okay, finally, we look at, I'm backing up a little bit. Then the next two standards are fish reproductive rates, which are measured as egg production of a selected number of 5 species that are fairly representative of different feeding guilds on the reef, and food chain support, which, as you recall, is the degree to which the benthic community provides food resources for the reef fish. And the food chain support is basically measured as the weight of gut contents of the various species of fish that are chosen. When there are two species chosen, a black surf perch, which is a predator near the bottom that feeds on smaller invertebrates, and the California sheephead, which is a larger fish that feeds on intermediate size invertebrates. Okay, so turning to the fecundity index, one can see that the time series for the fecundity index at Wheeler North Reef pretty much follows the trend, the time series for the two reference reefs, with the one exception here in 2016, where in barn, the barn kelp had a much higher fecundity index. And this is reflected in the 4-year running average in 2020, and where the Wheeler North Reef is higher, the index is higher than barn and a little bit lower than San Mateo kelp. So this standard was met in 2020. Turning now to the final relative performance standard, the food chain support. And there's a very different picture here. The food chain support has been much more erratic, much more variable over time. So sometimes it's below and sometimes it's within, and pretty much it's either below or within. And in 2020, actually, it is intermediate between the two reference reefs. And it just turns out that barn kelp had highest values, and San Mateo, the San Mateo kelp bed had the lowest values. So the food chain support index was intermediate between the two. And for the 4-year running average, that is the case for the 4-year running average as well, where the food chain support index was between the two reference sites. And so this standard was met. So the standard for fish reproductive rates and the standard for food chain support were both met in 2020. So recall, for the relative performance standards, the values of the Wheeler North Reef must be similar to the reference reefs. Wheeler North Reef must meet as many of the reference relative standards as the lowest performing reference reef in a given year for that year to count towards mitigation credit. The rationale for this is that requiring Wheeler North to meet as many as at least as many of the relative standards as a reference reef achieves the desired goal of Wheeler North being similar to the natural reference reefs without requiring it to consistently outperform them. And how we evaluate this: the Wheeler North Reef and the reference reefs are evaluated with respect to each other to determine whether they meet each relative standard. And then the total number of relative standards met by each reef is tallied and compared. So this slide summarizes that exercise in 2020. In this slide, the green dots indicate that the standard has been met. The red dots indicate that the standard has not been met. And for 2020, Wheeler North met 9 of the 11 standards, which is 3 more than the San Mateo kelp bed, which only met 6, the San Mateo bed being the lower performing of the 2 reference reefs. So as a result, the Wheeler North Reef met the relative performance standards in 2020. Okay. Now that is those are the results for the relative performance standards, and now we're turning to the absolute performance standards. These absolute performance standards must be met every year in order for the Wheeler North Reef to receive credit. There are 2 absolute performance standards subject to this requirement. The one is for hard substrate, and this requires that at least 90% of the exposed hard substrate that was the as-built must remain available for attachment by reef biota. The second absolute performance standard pertains to undesirable invasive species, and that the requirement is that the important functions of the reef shall not be impaired by undesirable or invasive benthic species. We evaluate this by basing it on the value measured for the current year or for the 4-year running average, which is calculated from the current year and the previous 3 years, whichever one is higher. Okay, so the next few slides deal with the performance standard for hard substrate. And this is done by measuring the footprint A of the Wheeler North Reef of phases 1 and 2 in sonar surveys, approximately every 5 years. And then we measure the percent cover of exposed rock, or P, using diver surveys. And then we calculate the area of exposed rock or exposed hard substrate as the product of A times P, the area times the percent cover. And we compare this area of exposed rock to that measured immediately after reef construction, that is the as-built, to determine whether 90% or more is still available for reef biota. There are a total of 9 substrate categories that we collect data on. And the categories that are used to evaluate the area of hard substrate are the top 5 indicated by this green rectangle: bedrock through cobble. Okay, here are the results of that monitoring. And the annual time series is on the left and the 4-year running average is on the right. And the solid horizontal line at about 72 acres is the initial or as-built area of hard substrate. And then the dotted line is the 90% of that standard. And what you can see is that the area of hard substrate at the Wheeler North Reef has never fallen below the 90% standard. And there is a particularly high value in this last year in 2020, which is like about 88 acres or something. And you can see that the running average, the 4-year running average on the right, is above the as-built, significantly above the as-built acreage. So this next slide kind of goes into sort of what's going on in 2020. As Dan pointed out, there were COVID restrictions. So normally for phase 1 and 2, we sample 82 transects for heart to determine the cover of hard substrate. And in 2020, due to COVID, we only sampled 15 of those transects. The first plot shows the footprint area as determined by sonar. And the sonar surveys show little change in the footprint area of phases 1 and 2 of the phase 1 and phase 2 reef over time. The middle graph shows the percent of cover of rock as determined by diver surveys. And the green triangles are estimates based on all of full monitoring of the 82 transects. And the open triangles are the results from the 15 transects that were sampled in 2020. The smaller sample size led to a greater variability, and that is less certainty in the estimate of the percent cover of rock. And when you multiply the acreage, the footprint area by the percent cover, you still see this high variability, and you see this very high estimate of the area of hard substrate. We believe that the reduced sampling of cover of rock in 2020 likely led to an overestimate of the total area of rock. And we are pretty confident that when full monitoring takes place in this year, that the numbers will be more in line with what the full monitoring in previous surveys. Okay. The second absolute performance standard I am going to discuss has to do with invasive or undesirable species. And that requires that the important functions of the reef shall not be impaired by undesirable or invasive species. Undesirable and invasive species that are of potential concern include high density of sea fans. So you can see the picture of the sea fans on the upper left. High density of sea urchins. You can see the picture on the upper right of sea urchin barrens, kelp bed, and high cover of non-native algae. And the two that we've focused on during our monitoring are the green alga, Caulerpa taxifolia, which is an escapee from the aquarium trade, and the brown alga, Sargassum horneri. Primary production by giant kelp and nursery habitat for young of year fish, as measured by the abundance of young of year fish, are used as indicators of important reef functions. Okay, these two graphs are time series for sea fans and sea urchins at the 3 reefs, Wheeler North and the 2 reference reefs. And one can see that on the graph on the left, the percent cover of sea fans is increasing disproportionately at the Wheeler North Reef, and so potentially could be a problem. By contrast, the average density of sea urchins at Wheeler North Reef has been consistently low and often much lower than at the 2 reference reefs. Okay, so what we did is we looked at the indicators of the health of the system by looking at how sea fan cover affected the net primary production of giant kelp or the density of young of year fish. And you can see that on both of these graphs, there is no relationship between sea fan cover and primary production or fish recruitment, that is to say, young of year fish density at Wheeler North Reef, when the data are detrended for time. So these are the values for the entire time series that we used here. Sea fans do not seem to be impairing kelp primary production or nursery habitat for young of year reef fish. The second evaluation we did had to do with the potential effect of high densities of sea urchins. And recall that sea urchin density was actually pretty low at the Wheeler North Reef, in many years much lower than at the 2 reference reefs. And again, we looked at, on the left, the net primary production versus sea urchin density, and yoi fish density as a function of sea urchin density. And you can see that there is no relationship between sea urchin density and kelp primary production or fish recruitment at Wheeler North Reef when the data are detrended for time. Sea urchins do not seem to be impairing kelp primary production, nor nursery habitat for young of year reef fish. Finally, looking at invasive, with actually these non-native macroalgae. No non-native benthic macroalgae were observed at the Wheeler North Reef in 2020. Invasive non-native benthic algae are not impairing important ecological functions at the reference reefs. They're not there. Okay. So with regard to the undesirable or invasive species, we conclude that there is no evidence that undesirable or invasive species are adversely affecting the important functions of Wheeler North Reef. And so this standard, this second absolute performance standard, was met in 2020. Okay, there are 2 more absolute standards. And these are measured differently than the first 2 that I talked about. And these 2 standards accumulate mitigation credit on an annual basis. The 2 standards pertain to giant kelp, and the requirement is that the artificial reef should sustain 150 acres of medium to high density giant kelp, which is giant kelp that has more than 4 plants per 100 meters squared. And the second standard pertains to the standing stock of reef fish. The standing stock of fish at the mitigation reef shall be at least 28 tons. We evaluate this as follows. The annual standing stock of fish and acreage of giant kelp at Wheeler North Reef are measured each year and summed over time until they reach a cumulative total equivalent to the annual target, which is 150 acres of kelp, 150 acres for kelp and 28 tons for fish, times the number of years of SONG's operation, which is 32 years.
Steve, you need to advance your slides.
They look, what do you see now?
The invasive species slide.
Okay, your sharing is paused. Okay, that's interesting. Okay. I don't know why that is doing that. Huh. Okay. Can you see that? You can see the invasive species, right? Dan?
Yeah,
Yep,
that's
that's
what we
right.
see.
Okay.
Sometimes,
and
Steve,
then,
if you can't get it to go, you have to quit and then reshare it. So
okay.
Oh, wow.
Let me stop
now-
share. Okay, because I got a little yellow message that says your screen sharing is paused. Okay,
yeah,
I'll stop share. I'm gonna share. I'm gonna go here. Share. Okay, can you see it now?
good.
Okay, so let me recap here. Sorry. So the two remaining absolute performance standards are for giant kelp, and the annual target for giant kelp is 150 acres of medium to high density giant kelp, and the standing stock of reef fish. And the annual target is that the Wheeler North Reef shall support at least 28 tons of reef fish by standing stock. The annual standing stock of fish and acreage of giant kelp at Wheeler North Reef are measured each year and summed over time until they reach a cumulative total equivalent to the annual target times the number of years of SONG's operation. I'm probably repeating myself, but so which is 32 years. Okay, so here are the results for kelp acreage. Again, the annual target is 150 acres of medium to high density kelp in any given year. And on the left, you can see the amount of the area of giant kelp in 2019, which was actually 34 acres. Wheeler North Reef earned mitigation credit for 4 acres of medium to high density kelp in 2020, resulting in a cumulative total of 38 acres of adult giant kelp, which you can see the cumulative on for 2019 2020 on the right. This slide shows the time series for adult kelp density, number per 100 meters squared at the 3 reefs, Wheeler North and the 2 reference reefs. And what you can see is Wheeler North Reef was either much greater or between values at the 2 reference reefs. And there has been a decline in kelp abundance since 2017 that is pretty much mirrored at Wheeler North and the 2 reference reefs. The bottom pictures show young kelp plants, blades and juveniles observed on the phase 3 polygon that was constructed in 2019. And the appearance of these young kelp recruits gives us, makes us optimistic that going forward, the expanded Wheeler North Reef is likely to get a lot of kelp and fulfill the cumulative standard. The second standard for fish standing is for fish standing stock. Annual target is at least 28 tons of reef fish standing stock. You can see on the left, 2019, Wheeler North Reef had about 18 acres of, 18 tons of fish standing stock. And there were 22 tons of fish standing stock in 2020, resulting in a cumulative fish standing stock biomass of 40 tons, sorry. Okay. And this slide shows the annual time series for kelp fish biomass, grams per meter squared at the 3 reefs. And Wheeler North has consistently had values intermediate of the 2 reference reefs, and pretty much, with some exceptions, notably 2011, pretty much follows trajectory for the two reference reefs. So the biomass density of fish at Wheeler North Reef has been consistently within the range of the nearby natural reference reefs. This slide shows the species composition of 6 species that comprise 80% or more of the fish standing stock on the Wheeler North Reef. And this is shown for phase 1, the experimental reef, phase 2, established in 2008, and then phase 3 that was established in 2019, and phase 3 that was established in 2020. The species composition of the fish standing stock was similar on all 3 phases of the Wheeler North Reef in 2020. Okay, the relative performance standards. Okay, so this next slide deals with mitigation compliance. Relative performance standards and absolute performance standards for hard substrate and invasive and undesirable species. For these standards, 1 year of mitigation credit is given for each year that Wheeler North Reef meets all of these performance standards. Fulfillment of the mitigation requirement will occur when the number of years of mitigation credit accrued by the Wheeler North Reef equals the total years of operation for SONGS units 2 and 3, which is 32 years. The absolute performance standards for giant kelp and fish standing stock rely on accumulation of either kelp area or fish standing stock. Each performance standard is evaluated independently, and fulfillment of these mitigation requirements will occur when the total accrued acres of kelp or tons of fish standing stock equal the targeted annual value, 150 acres for kelp or 28 tons for fish, times the total years of operation of SONGS units 2 and 3, which is 32 years. Okay, this slide summarizes the earned mitigation credit for the Wheeler North Reef. In 2020, all relative standards were passed. The standard for hard substrate passed, and the standard for undesirable and invasive species passed. So the number of years of credit earned for these standards is 2 years. The number of years of credit required is 32 years, so the number of years of credit still needed is 30 years. Now for the cumulative standards, for giant kelp area, there was a credit of 4 acres in 2020. The cumulative total, including 2019 and 2020, is 38 acres. The credit required is 4,800 acres, 15 times 32. The credit needed is 4,762 acres. Turning to fish standing stock, there was actually 23 tons of fish standing stock accrued in 2020. The cumulative total for 2019 and 2020 is 40 tons. The credit required is 896 tons, 28 times 32. The credit needed is 856 tons. So that summarizes where we are in terms of the mitigation credit earned for the Wheeler North Reef, and that concludes my presentation. Thank you.
Thank you, Steve. All right, now we have time for some questions. I see that there's one in the chat from Mark Steele about area estimates of hectares or acres. And unfortunately, maybe Mark, you could you tell us what specific slide? I don't think we caught it when you asked the question. If you could just let us know what specific standard you're talking about, we can probably better answer that question. So if you do have a question, feel free to either type it into the Q&A box, or you can feel free to raise your hand using the raise hand button at the bottom of your screen, and I will enable you to talk and ask your question. So Mark is referring to the reef area standard. So maybe Steve, could you answer that question?
The reef area standard is acres. What is the reef area standard, or the area of hard substrate? It's acres.
I think the question was because of the numbers on your slide.
Uh-huh.
And unfortunately, I didn't see his question until after that slide was passed, that graph. But I think Mark Steele's, he looked at those numbers and he thought that they looked low.
Uh-huh.
So Mark,
Yeah.
Oh.
Mark, I've allowed you to speak. Mark Steele, if you want to chime in.
So just looking at the slides, it looked like the numbers were around 70-ish.
72.
Up around 150.
So Mark, the reason for those numbers, what he's doing is he's multiplying the footprint area by the actual percent cover of rock. And then so the footprint area would have been 170 some odd acres times X percent rock. And that's what gives you the 70 to 80 acres of emergent hard substrate.
Right. Okay. Got it. Thank you.
Okay, and now let's see, Chris Skolblatt, you've raised your hand. I'm going to allow you to talk. All right, you should be able to talk now. Go ahead and you can unmute and ask your question.
Presentation. If you could just clarify a little bit, the footprint is 378 acres, and that is that confirmed by multi-beam sonar once it's on the seabed? And the second part of my question is on purple sea urchins. Do you have anything that attributes to why Wheeler North Reef hasn't seen the purple sea urchin barrens where some of the benchmark reefs may have? So it's kind of a two-part question there.
Okay. So the first part is, the question is the footprint area. Yeah, I mean, that was based on sonar, multi-beam sonar. And why aren't there urchin barrens, purple urchin barrens at the Wheeler North Reef? That's a good question. I mean, but the abundance of purple urchins has consistently been very low at the Wheeler North Reef. So, and there are some urchin barrens at the San Mateo Reef, not at the barn kelp. So then the question is, why aren't there urchin barrens at the barn kelp? I mean, I don't know. That's a urchin barrens kind of come and go, and abundance of purple urchins has consistently been low at the Wheeler North Reef. So they have not formed barrens.
Thank you very much.
Any other questions? Give it one more minute. Okay, David, I'm going to allow you to talk. Hi, David, do you have a question? You should be able to unmute and talk.
There's the button. Can you hear me?
We can.
Yep.
It's nice to hear all of you and see some of you.
Yeah.
Been a long time. My question actually doesn't have to do with Wheeler North, but the brain trust of artificial kelp reefs is all gathered here. So I've been watching these projects in Santa Monica Bay. I believe they're mostly funded by the Bay Restoration Project. I think it comes out of the Federal National Estuary Program. And they're very small projects, I think, aimed at, trying to figure out how to get giant kelp back in and around the Santa Monica Bay area. I think most of the work is being done around Palos Verdes. And it seems to me they're focused on two things. One is growing kelp in the lab and putting transplants down on hard substrate, which I know we tried in phase 1 at Wheeler North, and it worked, but didn't work any better than natural recruitment. And then the other thing they seem to be focusing on is killing sea urchins. And it just seemed to me that, you know, the sea urchins come and they eat up the kelp, and then the urchins die off for lack of food. And of course, the kelp comes back later, as it always does. I just kind of was wondering what you folks who know about these things think of those approaches as opposed to just sprinkling some cobble on the sandy seafloor there offshore. I mean, if they're trying to get kelp back into Santa Monica Bay, I'm just puzzled why they're focusing on urchins and transplanting.
I have some biases about that. And I tend to agree with you, David. If you look at, for example, the Point Loma kelp bed, which is kind of probably the biggest kelp forest in the Southern California Bight. There are areas in the bed that have over many, many years have had urchin barrens, and those urchin barrens come and go. Sometimes they may persist for a number of years at a time, but then, you know, the kelp eventually comes back. You know, I don't know. Sea urchin removal seems like kind of not a very effective way of ensuring giant kelp coming back. And there's a lot of data that shows that, you know, kind of kelp comes and kelp goes, regardless of the status of you know, urchin barrens in the kelp bed, because the urchin barrens very rarely you know, take over entire kelp forests. So it's kind of my bias.
Yeah, David, this is Dan. I think there's multiple things going on at Santa Monica Bay and Palos Verdes. I think the artificial reef they're putting in was designed not necessarily to replace kelp, but to replace some of the fishing grounds. So it's a relatively small footprint reef, my understanding, that's relatively high relief, that was designed to sort of attract and support high densities of fish. I think the sea urchin removal effort is an effort that has been going on for quite some time over the broader Palos Verdes area. And it's something Wheeler North looked at back in the 50s and 60s as well. And yeah, I don't know. I think there's differences opinions on the effectiveness of urchin smashing, but
yeah.
But urchins can, I guess I would disagree with Steve in the sense that urchins can take over entire kelp beds and create barrens. And if you were to get rid of the urchins, typically the kelp comes back. The question is, how feasible is it to, and how ecologically sound is it to remove urchins over large areas? So that's, you know, that's really not a science question as much as maybe a societal question.
Yeah, thanks, fellows. I don't know, maybe Kate, this is a question or a comment for you, but you know, it seems to me along Santa Monica Bay that the root cause is we've dammed up all these little creeks with catch basins, and when they get full of sediment, they dig the stuff out and probably take it to a landfill. The cobble is not being delivered to the shoreline anymore. And it would seem to me if that were the case, if the cobble were transported back to the shoreline, kelp eventually would start showing up, you know, on the seafloor, like at San Onofre, where it's mostly cobble and small boulders. So Coastal Commission staff thinking about anything policy-wise to help things along in that area?
You know, I have not. I'm going to mute you, David, because there's an echo. Okay, sorry. So I'm not aware of a particular policy direction on kind of the larger cobbles. It's interesting though to think through. We've really focused on mostly on sand and keeping sand in the system, and so instead of depositing, for example, dredge spoils out in the ocean, trying to keep usable or sand that's appropriate appropriately sized and clean on the beach to keep it in the littoral cells. But it's an interesting concept to think through the kind of the larger grain size, whether it's cobbles or boulders, and what happens to those. I don't follow the Santa Monica Bay situation as closely, so I'm not aware of any projects, but I will start paying attention.
Thanks, Kate, and thanks all of you. It's good to check in with you every now and then. Maybe I'll get Hani Elwani to apply for a grant or something, and we'll go out and build a little reef off of Santa Monica. You can help us with the permit. Thanks again.
All right, looks like Chris Goldblatt has another question. I'm going to allow him to talk, and that'll be the last question until we move on to the next set of talks, because we're a little over our time. Yep, Dan?
Kenny Nielsen's had his hand up for a while too, so.
Oh, I am not seeing that. Okay, that's not showing up. Let me first allow Chris to talk, and then I will see if I can't figure out how to bring Kenny Nielsen in. Okay. Chris, you should be able to unmute yourself and ask your question.
Be quick up. But David Kay's comment was very poignant. I feel duty bound to comment on the destiny of cobble and rock coming off the mountainsides, and how that appears to be absolutely necessary to recharge a lot of the reef systems in the shale-based ecosystems in the Southern California Bight, especially in the Goleta area down to about Rincon, where historically, when you had those 100-year storm events, those large rocks and cobbles would repopulate that entire area. We had a 1,000-foot wide kelp bed that ran for 20 miles, and it's really only there in areas where you have high relief off of areas like Hendry's Beach and Isla Vista to prove that point. And the floods that we had in 2017, where you had these massive boulder slides, most of those were stopped from going into the ocean through hedges and houses and Caltrans taking them away and stuff like that. And that deprives the system of the entire next generation of hard bottom. So projects that seek to restore and emulate what mankind is stopping from going in the ocean in the first place would seem to be highly appropriate to meet the terms of the original Coastal Act to reinvigorate and sustain our kelp forests. So we're kind of duty bound to do everything we can in that regard. I think everybody knows that the Fish Reef Project is working on that through our design reefs. It's called sea caves up in the Goleta area that are designed specifically to fill in that gap where mankind is stopping that material from going in the ocean in the first place. So hopefully everybody will stay tuned and see how we do there. And hopefully we can bring those kelp forests back through what is really a very simple technology. Thank you very much.
Thanks, Chris. All right, Ken, I'm going to allow you to talk. You should be able to unmute yourself and ask your question.
Okay, can you hear me?
Yes, we can.
Okay, thank you very much for the opportunity. As far as these gentlemen looking for cobble, I don't think they've looked at our beaches lately in San Clemente. We've got 90% cobble and no sands, so there's no shortage of cobble between San Clemente and San Onofre, but if they care, if that helps a little bit. One thing I wanted to bring up, when they installed the last portion of the reef, they actually went up into areas where we had been fishing for years on reefs that we fish, and they put a lot of rock in that area. And we tried to call people about it, never got anywhere. I don't know why they did that at the far end. It's to the fishermen, it's called Christmas tree. But anyway, the lady that I finally got a hold of said, well, they asked all the fishermen about it and they said it was okay. But I asked her who the fishermen were and she couldn't remember. So anyway, if that's important, Dana Wharf Sport Fishing was supposed to be having someone speak today, and I haven't heard them yet. And they fish all those areas constantly. But One last thing, I don't want to carry on much, but I'd like to see the Coastal Commission look at toning down the requirements. We've got the reef in now, and unless you want to double the size of it again, it's still going to be 32 years we have to monitor it every year. So either monitor it every 5 years or every 10 years, or I don't know what. I can't imagine the amount of money we're going to spend to maybe meet the requirement. And we've got the reef. All it's going to take is time. It's going to do fine. So anyway, that's about it. Thank you.
Thanks, Ken. I guess I can respond to the last part of your comment there about the monitoring. The requirement was for the reef to meet the requirements, as you well know.
Yep.
For the life of the San Onofre power generating station.
Right.
So, and that is 32 years. So, but there are requirements in the permit that include reduced monitoring once the reef is on the right track. And so we anticipate, if things kind of continue the direction we think that they've been headed, and that we should enter into that reduced monitoring paradigm pretty soon, within the next few years. So it's there will be reduced monitoring, but there will be monitoring for.
Right. I understand
2 years.
I understand that doing some monitoring, but our first speaker tonight said the reef is doing very well as a reef.
It is.
And I mean, I can see it. I can see the kelp growing well, not so much on the new portion because it's new,
Right.
but it will be. And none of that area is good for counting fish anyway, because it's dirty so often. Though you see all the pictures you show in here, how many fish are in one picture? So I don't know how they are not getting the tonnage on the fish. But anyway, I'd just like to see the monitoring toned down a little bit and not spend how many hundreds of millions of dollars monitoring it till we may get to the point where it's enough, or is it a never-ending story? Thank you.
Thanks, Ken. All right.
So Kate, I'd just like to respond to your first question, Ken, and we'll talk a little bit about that in one of the presentations coming up in the construction monitoring, in terms of placing the new reef in areas of existing reef. So then maybe we can revisit your question then, if you still have more questions on that.
Thank you.
All right. Why don't we move on to the next set of talks on the expansion of Wheeler North Reef. So I think Jenny's up next at Edison. Jenny, are you able to share? We just saw your talk and then it went away. So are you having?
Yeah, okay. Let me try sharing again. Sorry about that.
No problem.
Let me get all the right things up at the right time. All right, can you see it now?
Yes, we can.
And you can hear me now?
Yes, we can.
Okay, we'll roll with that. I'm not going to try video. That might just do too much. Okay, so thanks everyone for letting me join the talk today. I'm Jenny McGee from Southern California, Edison. I'm the project manager for the Wheeler North Reef expansion project. And I just want to say a quick thank you to the Coastal Commission and the research team for giving us an opportunity to speak today. Okay, so the third phase of the Wheeler North Reef became known as the Reef Expansion Project. Steve and Dan already gave a really good overview of how we landed with the expansion project, so I won't go into detail about that. But just very briefly, Edison developed the scope of the 200-acre low relief reef based on the scientific studies, bathymetric surveys, and our partnership with Coastal Commission and our contractors. And essentially, we had then provided a series of options that we could implement to address the need for the remediation reef. Edison selected what was known at the time as option 1, and that consisted of a 200-acre low relief reef. The reason we selected this design option was because we had 3 primary reasons. First, it was similar in design to the existing reef, which, as you saw, we had 9 years of data that showed that it was well studied and demonstrated performance. So we knew that it was effective in growing kelp and attracting fish and associated development of kelp habitat. The second reason was because it requires the least amount of rock, which is a major cost driver of the project. So that was an intentional effort to minimize the cost of the project. The third was because the design aligns with the impacted Onofre kelp reef, which made it particularly good fit for the expansion project. The expansion project would require over 150,000 tons of rock distributed over 200 acres of the ocean floor. The rock was sourced from 3 separate quarries, the Empire Landing Quarry and the Pebbly Beach Quarry on Catalina Island, as well as one quarry in Ensenada, Mexico. The transport of the rock required 44 barge trips. It actually required 49. This was our scoping, 44. And the project was originally estimated to cost $30 million. However, after we fully scoped the project and permitted the project, that estimate was revised to be $20 million once the licensing requirements and permit conditions were all put into place. Really quick on permitting the project. The project itself is a substantial marine construction project and did require a full CEQA environmental impact report. Our partners over at State Lands Commission were the lead agencies of this of the EIR. We also were required to secure a permit through the Water Resources Control Board, an environmental permit from the Army Corps of Engineers, of course, our Coastal Commission permit, and we also had to purchase air quality offset credits as part of the CEQA process. And lastly, we did expand the state lands lease that we hold offshore for the project. Once all the permits were in place, the project was able to proceed with construction. The construction was completed in 2 seasons. This was largely driven by two main factors. One being that we had a substantial amount of rock that needed to be secured for the project, and sourcing that work, the rock, was a considerable amount of work, but also a lot of logistics and timing. The photo here is the Empire Landing Quarry, and you can see right there on the shoreline a stockpile of the Wheeler Reef rock that would be transported from that beach over to the project site using the tugboat pulling a flat deck barge, as you see in the other photograph here. This particular quarry sourced for the majority of our rock for the project, that, as you can see, has a really limited space in terms of area to stockpile. So the timing had to be very precise. Once the rock was brought over on the flat deck barges, you can see here in the lower right photo, you can see our construction barge. This is the Derrick Barge Long Beach. And the Derrick Barge Long Beach was positioned by 6 different anchors, and the flat deck barge was then aligned in parallel, bow to bow, with the derrick barge, and the derrick barge crane boom would then lift the front loader onto the flat deck barge, as you can see in this upper photograph. And then the construction consisted of essentially aligning the two ships on the coordinates of the project design. And once the positioning was verified using our spatial positioning systems on board, the rock was allowed to be pushed off. A little bit about our marine monitors. We had on the project 3 full-time marine wildlife monitors on the barge itself, the construction vessel. The monitors were responsible for identifying all marine animals and notifying construction personnel if an animal moved within the exclusion zone around the barge. So we had one monitor facing in opposite direction, so they had a 360-degree view of the derrick barge and its surrounding waters. And they rotated every hour to make sure that they were fresh and alert during all their observation rotations. The monitors had a stop work authority, which they communicated over a dedicated radio channel to ensure immediate response by construction teams. This protocol was implemented to avoid collision or harm to animals. Interesting, during the construction season, the monitors issued a total of about 23 stop work orders per season. And we had significantly more sightings in 2020 compared to 2019 as the construction was closer to Dana Point Harbor. We saw approximately 1,200 animals during 2019, about 230 of which were in the exclusion zone, and 4,800 animals were sighted during 2020, with about 240 in the exclusion zone. The vast majority of the animals were common dolphins cruising outside of the exclusion zone. However, in the mornings, it was common to see a sea lion hauled out on the rock to rest. We show here a picture of Rocky. He was a pup that was frequently out on the rocks, as he seemed to have an affinity for hanging out at the highest point on the rock barges. Next, we have, this is an overview of the construction verification process, and I can speak to your comment a little bit, Kenny. So just to speak about the graphics here for a moment, what we did was we tracked each of the source of the material and the placement of all that material. So we mapped which quarry, because each of the 3 quarries sourced the rock, it was slightly different material. So we mapped out where each position of, where each type of rock from each quarry was positioned within each of the polygons. You can see here the spacing on the left. Each one of these little lines was a placement of rock. And overall, that constructed the polygon. This is the CAD data that was used on the ship's system. And we had spatial identification systems that were surveyed and verified on both the derrick barge and also on the flat deck barge. And so we would see during construction the placement of the barge overlaying on these lines. Once the placement was verified, that was when they were authorized to go ahead and push. The placement of the material was extremely highly accurate and to the design. In this position, you can see in this image the distribution of the different material of the rock from the different quarries. So we can see that yellow is from Pebbly, the green is from Ensenada, and the orangish color is from Empire. Here is our graphic of the as-built of the reef. You can see the polygons of the expansion project in relation to the first and second phases of the project. So this is what our reef looks like now, collectively. We have here some images. These are pulled from 2009, and looking forward to looking forward to seeing what our new reef is going to be growing and supporting. I enjoyed seeing these pictures of the baby kelp that Steve showed earlier. Lastly, I'll wrap up with just an overview of the project by the numbers. Edison was very pleased with the outcome of the project. It was executed per design and as a permit. We completed the project on budget, ahead of schedule. Consisted of 20 new polygons of quarry rock. We executed with our team almost 42,000 man-hours worked without incident, either environmental, compliance, or safety incidents. We had a placement of a total of 173,000 tons of rock, a total of 49 barge trips, and 3 separate quarries comprised of sourcing the material. The outcome was 3% above our hard substrate requirement. And ultimately, our partnership with Coastal Environments and with Connolly Pacific Marine Construction Company, the team really executed a project that was consistent with Edison values, upholding integrity, continuous improvement, excellence, teamwork, and safety, putting that above all. And lastly, I'll just touch really briefly. The second phase of the project was constructed during COVID. There was a point where it was a lot of extra effort to make sure that we could proceed with the project, and we couldn't have done it without the research and science team. So really grateful for the partnership there as well. We implemented extra sanitation stations. We required mask wearing when social distancing wasn't feasible. You can see here on the transport crew vessel, you have to stand in really close space. Everybody was masked up, but really great teamwork by the folks. So, and that's all I've got. Thanks. Can you guys still hear me?
Yep, we can. Dan, are you ready? All right, he's starting to do the next presentation. Thanks, Jenny.
My pleasure.
Unmute. Okay, so I'm just going to follow up on Jenny's talk with some of the construction monitoring that was done on the phase 3 expansion. And the purpose of the construction monitoring was to verify that the reef was actually built according to plans and that it met the requirements of its coastal development permit. So some of those requirements I've listed here. The first had to do with the size and rock coverage of the reef. The idea was to build a 200-acre reef with at least 42% cover rock or an equivalent of that. That means the reef could be maybe half the size, but twice the rock coverage, or somewhere in between there. The reef also had to be low relief, no more than 1 meter high, and that's to kind of try to mimic what the San Onofre kelp forest was like, which is a natural cobble reef, the low-lying reef. There was also concern to try to avoid placing the artificial reef in areas of existing natural rock. And so there was some acknowledgement that it might be inevitable that some rock would be placed in areas of natural rock, but the requirement was that it could not be placed in areas where the natural rock coverage was 30% or more. The reef was to be built in water depths of 28 to 49 feet and in areas that had a relatively thin sand layer to ensure that if the rocks were to sink in the sand, they wouldn't completely disappear. And so the first of these requirements were determined by monitoring after the reef was built, whereas the last 2 requirements were determined by monitoring that was done before the reef was built during the project siting and design phase. And so what I want to do is focus on these first 3 requirements here that were determined by monitoring after the reef was built. With regards to estimating the reef acreage, that was done using bathymetric data from multi-beam sonar surveys that were conducted by Coastal Environments, which is led by Dr. Hani Hawani, who has a long history with this project. And what they did was they used the bathymetric data to delineate the boundaries of the 20 phase 3 polygons. Now, the surveys that they ran covered 100% of the project area, and that's shown in this bottom left-hand diagram here, where these are the vessel tracks that shows where the surveys were done. Those surveys were completed in October 2020 after both the phases were completed. And they used the same methods to survey this area as they did to survey the phase 1 and phase 2 reefs in 2009 and 2014. Now, the bathymetric data were analyzed using a multi-beam processing software, and then they defined the boundaries of polygons as the interface between the sand and the rock. And you can see that in this this figure on the right-hand bottom here, which is taken out of the construction report. And the solid line you see is the actual area measured based on the bathymetric data. And the dashed line is what the designed area was, what the planned area was. And you can see that they actually were pretty accurate, as Jenny was saying, in placing the rock. It really fell within the boundaries of the designed area. You can see in the area below the polygon here, below polygon 19, the bathymetric map is pretty featureless, indicating that this is largely a bare sand area, whereas above this polygon, you can see that there's what appears to be a higher relief in this area, which is most likely natural rock. And so they were trying to nestle these polygons within areas of existing sand that were bounded by natural rock. So the area of quarry rock in the middle of these polygons, the percent cover of that, I should say, was determined by diver surveys. And what was done here is transects that were 50 meters in length were distributed across each of the polygons at a density that was proportional to the polygon area. So for instance, large polygons tended to have more transects, proportionally more transects than smaller polygons. Each transect was 50 meters in length, and they had 5 1 square meter quadrats placed at 10-meter intervals along the transect. There was a grid of 24 uniform points surveyed within each quadrat, and the type of substrate was recorded under each of those points. And so the percent cover of rock in each polygon then was determined from all the points sampled in the polygon. And it was weighted by the proportional area of the polygon relative to the combined area of all 20 of the phase 3 polygons combined. Okay, and that was done to make sure that to come up with a weighted average of the rock cover gave us a more accurate estimate of what the total cover of the all 20 polygons combined was. Now, the requirement for reef height, that was simply assessed by divers visually as they swam the transects, and they would note if they saw any aggregate piles of rock that exceeded 1 meter tall. Okay, these are data then from the results from the sonar survey, and the graph shown at the top, at the bar graph at the top, and the diver surveys of rock coverage on the bottom. Each bar in these figures represents one of the 20 polygons, and you can see from the sonar data that the polygons ranged in area from polygon 20, which was this large polygon down in the southern portion of the reef. It was about 28 acres, where some of the smaller polygons in the more northern portion of the reef, they were on order of just a couple acres. But when you added up the acreage of all the polygons, it came up to 197.4 acres. Now, the diver surveys, what's plotted here is the percent cover of rock in each of these polygons. And when you weighted that percent cover by the proportional area of the polygon, then the average rock coverage over the entire 20 polygons was 45%. So the way we estimated the coverage of natural rock within the phase 3 polygons, we relied on bathymetry maps that were based on surveys done in 2016. So these were surveys before the phase 3 expansion was built. And so the polygons then were located in these bathymetry maps. Here's a polygon 18, for instance, is shown, which looks to be in an area that's relatively clean inside the polygon, suggesting this area inside this polygon is all flat sand. Whereas if you were to look, say, in polygon 37, it looks like there's some outcrops that appear in this polygon, and it's surrounded by much larger outcrops on the outside of the polygon. So what we wanted to do is to verify if in fact this was natural rock that was existing in the polygon before the new rock was built. Unfortunately, we couldn't go in and measure the existing rock once new rock was dumped on top of it. And so what we did was we conducted surveillance dives in the summer of 2020 to verify that those areas that we identified as potential areas of natural rock from the bathymetry maps of 2016 indeed were natural rock. And these photographs show that to be the case, actually. You can see natural rock in some of these areas that had Mauricia, relatively long-lived colonies of Mauricia growing on this natural rock. You can see the new rock from the phase 3 expansion deposited on top of that. Bottom photographs show an understory kelp, Pterogophora californica, on some natural rocks surrounded by some new rock that is scattered in this area. And so, so what we were seeing in the 2016 bathymetry maps was verified by the diver surveys. Once we verified that, we went back to these 2016 bathymetry maps and we calculated the area of these outcrops that were in the maps. And then we calculated the total percent cover of rock within each of these polygons simply as a fraction of the area of the little outcroppings in the polygon as a fraction of the total area of the polygon. Okay, so here are the results from that overlap with natural rock. And what we found was that 8 of the 20 phase 3 polygons were found to have natural rock in it. And all 8 of those polygons were in the northern portion of the reef. The percent cover of natural rock in those polygons was much less than 30% allowed by the coastal development permit. And you can see that in this left-hand column here that shows the percent cover of natural rock in each of these 8 polygons. It ranged from 0.05% in polygon 29, which is this guy right here, to 7.26% in polygon 34, which is this very small little polygon located up here. The total average coverage of rock across all 8 of these polygons was 2.87%, and it covered 2.14 acres. So to evaluate then these 3 requirements, with regards to the requirement, the reef be 200 acres with at least 42% cover of rock or an equivalent of that, we found that this requirement was met as the as-built showed 197.4 acres with 45% cover of rock. They only needed 186 acres with 45% cover, so this requirement was met. The requirement that there be low relief, no more than 1 meter tall, that requirement was met as we did not observe any areas where rock was stacked higher than 1 meter tall. And the requirement that the reef be built in areas where the natural rock coverage was less than 30%, that was also met as natural rock was observed in only 8 of the 20 polygons, and it ranged in cover from 0.05% to 7%. That natural rock accounted for 2.14 of the 197.4 acres, or 1.1% of the total footprint area of the phase 3 expansion reef. So based on these results, we conclude that the Wheeler North Reef expansion was built according to plans, and it met all the requirements of its coastal development permit. And so with that, I'm happy to answer any questions. And I will bring up the agenda in case anyone wants our website.
Thank you, Dan. So if you have a question, now is a good time to either type it into the Q&A, or you can raise your hand using the button that should be at the bottom of your Zoom screen, and I will pull you into the meeting and allow you to speak. Anybody have any additional questions? All right, we'll give it one more minute. I'm not seeing any raised hands or questions in the Q&A just yet. All right, well, that is, it kind of opens it up for any general discussion. If you have questions, either on any part of the presentations you heard today or the program in general, we can take any kind of questions or just discussion points now. So again, raise your hand or you can type something into the Q&A if you have something you'd like to ask or discuss. A quiet bunch today, I guess. All right, well, oh, Ken, I see you have your hand up. So I will bring you into the meeting. You can unmute yourself and ask your question.
I just one quick question. Since things are getting better, how much longer are we going to be monitoring this reef?
A minimum of 30 years.
Yeah. Maximum of?
That depends on whether criteria are met.
Yeah,
So
I think
unclear.
you need to change that. Make it a little easier. We got the reef. Time will tell, and if God wants kelp to grow and fish to grow, they'll be there. Thank you.
Well, I think we're still at the phase where we're trying to assess the new reef and see how the entire reef is now going to operate. So again, we will be moving likely to reduce monitoring soon. And it's possible that in the future we'll revisit their requirements, but that's not on the horizon right now.
Hey, Kate, this is Pete. Can I jump in for a second?
Please, yes.
So we've gone over this in this meeting, but also in the past, but the whole goal of the expansion of the reef in particular was to shorten that time period. So it meets the relative standards, which means the reef works well, as you've pointed out. And the key issue were these absolute standards because they needed to meet each of those absolute standards, the kelp and the fish and all the other ones, but those were the two problem ones every year for a credit to be attained. And so by decoupling that now and just accumulating credit through acres and tons, and then assuming that the reef continues to operate well like it has in the past, we envisioned that the period is going to be dramatically shortened compared to what it would have been pre the expansion. And in fact, I think it would be as soon as 3 years from now that we would be going to reduce monitoring, assuming that the relative standards stay consistent on the original Wheeler North Reef, which I think we call Wheeler North 2 at this point. So it should reduce both the time and the expense, at least for the relative monitoring, in short order.
That's good to hear. Hope I live long enough to see it. Thank you.
Thanks, Ken. Thanks, Pete. All right, we have another hand raised. Susan, I will pull you into the meeting and allow you to speak. You can unmute yourself and ask your question.
Okay, hi, yeah, I think Peter just kind of answered my question, but I just a layperson, I was just curious, like now that this phase 3 is there and you've got information from phases 1 and 2, like how many years are we talking about till it's kind of functioning as a normal, healthy reef out there?
Again, I'll comment on this really quickly if that's okay, Kate.
That'd be great. Thank you, Pete.
The key thing is that the key thing to keep in mind for everyone listening is it already is functioning like a reef, like a natural reef. The key problem was that it wasn't large enough to meet the requirements for the size, both with respect to kelp all by itself, but also size is related to the amount of fish in terms of times that can be on the reef. And so again, that has been remedied, we believe, and probably remedied in a way that will shorten that period of time until that accumulated tonnage. I think it was 896, Dan, I can't remember, but something like that in terms of tons, cumulative tons, and around 4,000 for acres. That should happen much quicker than it would have. It might have taken, many more than 30 years before phase 3, and now we think it's going to take many years, fewer than 30 years.
Right, awesome, thank you.
Any more questions?
Hey, Kate, I was just going to add, can you hear me okay?
Yes,
This is Jenny.
we can.
Yeah, I was just going to add to that, the reason, part of the reason why and the deciding factor for Edison selecting the design we did for the expansion was because we had data indicating the reef had been performing well. It was just a verification for us, and that was powerful enough to know that, you know, it was the right path in scoping and designing the project moving forward. And I just, from an Edison perspective, we just really appreciate the partnership that we've had. I think this is exemplary in being able to partnership with our agency partners and the research team, as well as our consulting and contractors. And I think the public transparency has been really excellent as well. I know we've had in the past all of our workshops down there in Dana Point in person. And we've publicly notified folks, you know, to please come and join us in these conversations. So I think that there's been a really good effort in the transparency and the partnership that's led the project to this point. And we're very pleased with it.
Thanks, Jenny. Any other questions? All right, then I think we can conclude our workshop a little bit early today. And if you do have any follow-up questions, something that comes up later for you, you can feel free to reach out either to the UC Santa Barbara team through that, through the website that you can, and maybe Dan, would you mind sticking that back up on the screen real fast, that the web address? If you'd like to reach out to the Coastal Commission staff. If you look in the chat box, I think Jonna Engel, who's our senior ecologist, has put her email in the chat. You can feel free to reach out to her and she can direct you to the right person depending on your question. So hopefully between those two, yeah, and if you just, this on the, at the very bottom of the screen is the web address for the UC Santa Barbara songs, marine mitigation website. And that has a lot of information, but also contact information for our team. So if you have any questions, feel free to reach out. We will, as I mentioned at the beginning, be posting a link to this, to the recorded version of this webinar up on that website. So you can feel free to pass it on to anybody who wasn't able to attend or go back and look at it if you're so inclined. So with that, I'd like to thank everybody for coming today. We really appreciate you joining us, and we will, oh, I've just got a comment, chat, right. So the chat function is disabled. So Jonna, would you please just put up your email address in the Q&A real fast, just so that we can make sure it's accessible to everybody. We will do that.
Okay, so to put it in the chat, I'm looking to see how do I even, okay, I'll try it. Okay. I'm not able to add to the Q&A as maybe as a,
you can type an answer.
Yeah.
Oh.
You know what? I got it, Jonna. I'm doing it.
Okay. Okay, I see. Type an answer. I see.
Hopefully everybody sees that in the comment to Mia's, is Jonna's email address.
I don't see it.
I'll type the answer. I got it. Thanks. Sorry, I was not able to figure that out myself. Okay, there we go. Oh, we both did it, Kate.
Yep, exactly. All right. Well, thanks everybody again. We really appreciate it, your attendance and attention today and all the good questions and conversation. And just a reminder that we'll be having another public workshop on the wetland, which is coming up. What is, Steve, can you remind me of the date?
Yes, it is on May 4th, Tuesday.
May 4th, Tuesday. And again, I believe is it the same time frame,
It's
1:30?
the same time frame. Yep. Mhm.
Yeah. So we may see some of you there. And if not, I hope you have a great rest of your day. Thanks, everybody.